Okay, so I started off talking about the science of learning, and I'm guessing from the audience not everybody here knows what the science. If you're a learning scientist, raise your hand so I know who I'm talking to. Yes, Roy, I knew you'd raise your hand. Okay, so just basically the goal of the science of learning is to describe, explain, predict student learning. Just so you get a little foundation there. And in terms of where we do our work, in terms of understanding learning, there was an argument that was made about science in general a while back about there's if you a 2x2, so you know I'm an academic because I put up a 2x2 matrix. So if you do your work with a high emphasis on basic science, but a low emphasis on applying it to solve real world problems, then Stokes would have argued that you're in Bohr's quadrant. This was not based on education science, this was based on fundamental science. So education science is fundamental science. Anyway, so how do you, but then the problem if you're working in Bohr's quadrant, if you find some basic generalizable knowledge, then often it's a question of how do we translate it to do something in the real world. If you are working in Edison's quadrant, where you have a high emphasis on solving a real world problem, but a low emphasis on building our fundamental understanding, then we're saying you're in Edison's quadrant and your challenge there is what principle, so we solve this immediate problem, but what principle can we derive from that to solve other unlike problems? So that's the challenge in those two quadrants. There's also Pasteur's quadrant, where you are working, where you're co-creating your research so that you're co-creating it in such a way that we're solving a real world problem at the same time as we're facilitating or building to our basic understanding of, in this case, human learning. Now, this quadrant down here, you notice there isn't a name on it. Actually, when Stokes wrote this, he called it who's the bird book guy? Peterson's quadrant, and that's research that's motivated by the curiosity of the researcher. I simply tell my students that quadrant is the quadrant we call NSF will not fund. So I just tell them stay out of that quadrant. So this is where we try and stay, is up in Pasteur's quadrant. So what do I mean by using research to inform learning? One of the things we know is for some kinds of learning, goal-directed practice and targeted feedback enhances the quality of the student's learning. So you saw a big move for a lot of time where people were deconstructing complex knowledge and building these interactive environments where students were interacting with the environment, moving towards a goal, getting feedback, and we could show that we could actually accelerate learning in those kinds of environments. But we also know that in higher education, we want students not just to build fluency, but also to be able to synthesize disparate knowledge and apply it in new contexts to new problems they haven't seen before. So we also design environments that engage students in the practice of synthesizing and applying knowledge in new contexts. So I'm not going to go into great detail about how we do that, but I will if people want to know later. But one of the things I want to ask you, because you're all people that work in this space, when you think about technology and education and transformation, where's the big power? What's the affordance? And usually when I talk a lot of rooms, and when I ask some rooms, I get usually one of three answers. The first one, access and convenience. If you have access to a computer, you can learn anytime, any place. Access and convenience is how technology will transform education. The other one is simulation, personalization, that you can do things in an interactive environment that's really hard to do in a classroom. If you're teaching someone engineering, in a simulation, you can have them actually build a bridge. The bridge collapses, nobody gets killed. Or in biology, you can see things at that very, very microscopic level. We can show students what equilibrium looks like. So that simulation personalization, or if you, as our first speaker talked about, no, the power is not there, the power is connection. And as Michael Bernstein will talk later about crowdsourcing. The real power is we have a computer, it's not isolated, it's connected to a network. So we can connect to other experts, we can connect to material, we can connect to the world. So now I'm going to ask this room. If you had to place a bet on which of these affordances is going to transform education, where do you place your bet? So by show of hands, how many people think, no, it's really about access and convenience? Raise your hands. Be proud. Okay? How many people think, no, it's not access anymore, that's old school, it's all about these simulation capabilities? Okay, great. Now, how about, oh no, you guys are wrong, you're all thinking 20th century, it's all about connection. It's all about crowdsourcing connection. Okay, now how many people are sitting there thinking, Candace, you're a professor in the Graduate School of Education, what are you doing with this crummy multiple choice question? Yeah, okay, Martha was thinking that. So how many of you would wish that I'd had in there all of the above? Like, they're all important. Okay, how many of you have in there none of the above? Okay, because actually, I agree with you. Those are all important, but I would have picked none of the above. Well, let me ask you, before I tell you why, let me ask you this. How many of you just don't raise your hands when you're asked to raise your hands? Okay, yeah, got you to do it. Okay, so why do I say none of the above? It's because, do I have people in here from Google? Amazon? Netflix? LinkedIn? Any of these places? Okay, well, it's what they figured out. How many of you use Google, Amazon, Netflix, Facebook? Yeah? Okay, so what did they figure out? They figured out that the power of this technology is not using it to push it out, but to push it to the interface. Because in the interface, what can we do? We can observe you. And Amazon, Google, Netflix, all of those are observing us every day. And why are they observing us? Yeah, because they want to understand us better. They want to understand us better as consumers. So if we take that same idea and we push it to the interface, not, you know, some people think that's creepy, Candace, that you're talking about doing that with education, but actually we can understand learners better as learners. And both as learners individually, how do I serve you as an individual learner better, but also learners as a group. How does learning happen? And that's where it circles back to the science of learning. So the big power of this technology is we can construct these interactions, collect this data on the student's interaction, and use it to drive very powerful feedback loops in the learning system. So I already talked a little bit about giving feedback to the student so that they can continuously refine their performance. But we can also give feedback to the mentor or to the instructor so they can refine their performance. So now I use technology to support my teaching here at Stanford. And I teach on Tuesdays and Thursdays. In fact, I taught right before I came here. And I have my students work through a web-based open learning environment. And I tell them, finish working through that module on Monday night by 8 o'clock. Because I teach Tuesday morning at 10 o'clock. And I want some time, all those interactions you're making, the system's giving you feedback, but it's also collecting data for me and presenting a prediction about your knowledge on the things I care about. So one way that can look like, the particular course I'm teaching right now is a data analysis course. So here are some learning goals for that courseware, for that module. So one of the things, and that bar right there is a prediction about my students. Well, this isn't actually from my class. My students' bars look too green, so I wanted to show you one that had more variability in it. But what that shows is on each of those outcomes, by the interactions the students have made, run through a predictive model, the system is predicting that on summarizing, describing the distribution of a categorical variable in context, if I were to give my students an assessment on that today, they would nail it. Green. The one down here where we've got a little green, a little orange, a little red, that's just about a third of my students got it, about a third are kind of moderate, and about a third are struggling. Any idea what gray means?
Didn't do it.
Yeah, they haven't done enough work in the system for the system to make any kind of prediction. So then I can click in to any of those bars really quickly and say, who are those students? And how many activities have they done in the system that is making that prediction? I can also then look at the sub-skills and click into those and see the actual activities. But mostly I'm letting the system do a lot of the analysis for me. So I don't have to look at, oh, they did 23 of these and 64 of these. I'm looking at the underlying constructs instead of at the problem. So there's also feedback to the design team. The project I'm working on, just like we were talking about earlier, is an open educational resource. It's an open project. So the courses are not designed by an individual faculty member. They're designed by a whole team of people, distributed and varied. So lots of, in this case, statistics faculty, human-computer interaction experts, software engineers, learning researchers, all collaborating to co-create this environment that then multiple institutions use. So we collect the data on all of them. So the individual learner gets the data based on their performance, on their interaction. Their feedback is based on what they're doing. The instructor using the environment gets the data based on their class, who all is in their class that they're trying to teach. The course design team gets the data for all of the courses that are using that courseware that quarter, so that we can say, where is the design working? Where do we need to update it? And then, of course, the last feedback loop, near and dear to my heart, is to the learning researchers. So you might have the statistics courseware, but then you also have courseware in chemistry or in biology or in philosophy. And there are theories that are underpinning the design of those environments. And so we can look at refining the theory based on looking across the courses. Which brings me to why I think this is so exciting for learning research. It used to be when we would do learning research, we do one of two things. One of them is these randomized controlled trials, where we bring students into a lab and carefully construct the experiment, tightly control the variables, and then make some fundamental statement about what we learned about how people learn. The challenge there was often, from those kinds of lab trials, is all the things that we were controlling were actually part of the learning experience. So then when you tried to take that piece of theory and do it in the real classroom, you didn't see the same kind of results. The other kind of thing we do are classroom studies, where you do authentic investigations of going into a classroom and watching learning happen over long periods of time. And that provides a much more externally valid, rich description of learning. The challenge there, though, in terms of being able to extract some kind of underlying principle that then you could apply to a completely different environment, is there's so much going on that it's oftentimes hard to unpack what actually is making a difference, or what the interaction of things are that are making a difference. So you see a lot of times people will do a pilot study one place, people will say, oh, that's great, I'm gonna go do this over here, and they don't see the same effect. And I would argue that some of that is because they don't really know what was creating the effect that was created in the study that they did. And I would argue that using these environments, we can get the best of both worlds, because we can combine our theory and our practice and create these educational technologies that are testing our theories, but being used in authentic, real learning environments, and a great diversity of environments in a great diversity of contexts. And that puts us squarely back into past year's quadrant, where we're constructing. So then, now if you think about it, every time you're constructing a learning activity, what you're essentially doing is making a hypothesis. And then we can test that hypothesis by the students' interactions with that activity. So the science that this was based on originally when I was back at Carnegie Mellon was mostly cognitive science. So we take these complex cognitive tasks, we deconstruct them, create guided learning experiences with this targeted hints and feedback, and we showed that we could actually accelerate learning. So I can show you papers where we demonstrated in multiple contexts that we could significantly accelerate learning. But now that we know, and we heard sort of Kathy speak to this, a lot of what we want students to get out of higher education is not content anymore. Mastery of taught content is not what we really care about anymore. What we care about is how well can that learner put in a new situation, how well are they prepared to actually learn something new. So preparation for future learning. So how do we build environments that support learners and assess learners for their ability to actually prepare for future learning? Also, I've gotten a whole new group of fellow researchers here at Stanford. So in addition to looking from the cognitive perspective, we can also look at the social psychological perspective and say to what degree does a student's academic mindset have an impact on their success in achieving their learning goals, and are there ways that we can intervene if that is the source of the challenge to support students to develop a growth mindset? Or senses of social belongingness. How much is the achievement challenge not cognitive, not even a mindset, but I just don't feel like I actually belong here, so it's hard to engage. And this brings me to where I think what the platform needs to do. So we've got these two different approaches. One of them is starting with our theory. So we start with the theory that we've developed over decades. And as I said, we can create testable hypotheses in the learning environment. And then we also have all of these new approaches, which others are going to speak about, where we can start from the data and see what patterns do we see in the data. So we can go from, and I would argue that neither is sufficient, that we actually need to be approaching this from both directions. Do testable hypotheses based on what we know, but also look for patterns in the data to help us lead us to thinking about things that we hadn't thought of before. And that brings me to the big, how is higher education going to be transformed by technology? It enables this virtuous cycle of continuous improvement at all levels in the learning system. So we can start any place. We can start with our theories or our existing models of learning. We use those to design the learning experience. We then use the technology for what it's really good at, collecting the data. And then we analyze that data and then use that to refine our theories and our models, which we then use to redesign the learning experiences. And through this continuous cycle, we'll ultimately transform higher education. So I will now say about the platform piece. One of the things that we really need in order for this cycle to run is an open analytic system. So that irrespective of what kind of learning management system or learning system you're using, it can throw data out to an analytics service where you can hold these mappings to what's going on in the system, to skills, concepts, outcomes, whatever you want to map them to, where you can also put in your predictive models that are peer reviewable and open for debate, that you can use those and then visualize that to feed that back to the actors in the system, so that everyone has an opportunity and what the big concern I have right now is how many of those models are, on this side, are the data that's being collected and modeled and we're learning from it is in proprietary systems that don't forward our research, don't help us as a community understand how learning's happening and how to design the learning environments. So not only do the front end, not only do the learning environments themselves need to be open, but the back end data collection and data analytics need to be open, because this is an active area of research. So I will just close with a quote from Herb Simon, who was way long ago, former colleague at Carnegie Mellon. And back in 1991, he said, not the stuff in parentheses, he said, I modified what he said. Back in 1991, he said, improvement in post-secondary education will require converting teaching from a solo sport to a community-based research activity. And I kind of modified that a little bit to improvement in post-secondary education will require converting teaching and platform development from a solo sport to a community-based research and design activity. That's it.